Today's notes are 7.2, 7.2 notes. The basics of logarithms. A lot of our notes today will be examples. I think that'll help us make the most sense out of this new topic. Example 1, 2 to the 4th. Just kind of a review. What is the definition of 2 to the 4th? That means to multiply this base, label that the base, times itself 4 times. So 2 times 2 times 2 times 2. Does that equal? 16. Good. Logarithms come into play when we don't know the exponent. So figuring out the unknown exponent is what logarithms are all about. Sorry, I didn't mean to write example 2 yet. I'm going to show you what this looks like in logarithmic form. We could rewrite this as log base 2 of 16 equals x. It always helps me to kind of be able to translate that word log into kind of a mathematical action. So you could read that as what power do we raise 2 to get 16? 16? What power do we raise 2 to get 16?
So like, if the 2 is on the bottom, it would be like, put exponent next to it. It's like, what you need to get to 16.
Mm-hmm.
I'm sorry.
That's okay. So we're going to take a look at another example. Log base 3 of 81. We're going to restate that in exponential form. It's helpful to be able to identify the pieces. The 3 is the base. The 81 will become our solution. And I forgot to write equals x. The x will become our exponent. And I have a special method. It's called the counterclockwise circle rule. I'll say it again, the counterclockwise circle rule. Say that 5 times fast. So it goes from the base to the exponent and then swirls back around to the solution. If you can remember that counterclockwise circle, it makes it super easy to restate it in exponential form. So we would write the base to the exponent power equals the solution. Everybody see how that worked? Make sure you write that in your notes. So it makes a circle around and helps us remember what goes where. Now we have to solve for x, right? X equals 3 to what power is 81? This is where last Monday's opener, we did that whole list of 12 different values raised to, I don't remember, different powers. You could reference that, or you could just guess and check and start typing in. Well, we know 3 squared is 9, so then go back to your calculator and just keep that. Logan?
It's 3 to the 4th power.
Fourth, okay. Good, so 3 to the 4th equals 81. So in this lesson in 7.3 as well, the goal is to kind of become familiar with going back and forth between the logarithmic form and the exponential form of equations. Example 3, log base 6 of 216 equals x. And you can apply the counterclockwise circle method. We could rewrite that as 6 to the x power equals 216. And then again, you can type in 6 to some power is 216. What is it? Olivia? Third. Good. Example 4. Log base 100 of 1 equals x. That translates to 100 to the x power equals 1. Anybody know what x is? Aaron?
0.
Yes, x equals 0. Anything to the 0 power is 1. That's kind of a tricky one if you forgot that. Example 5. Switch it up on you here. Log base 5 of x equals 4. Same counterclockwise circle rule applies. So 5 to the 4th power equals x. This is even easier than the last one, turns out. So what is 5 to the 4th power? Odyssey? Nice job. X equals 625. Do one more like that. Log base 5 of x equals 4. Sorry, 3. Sorry, I rewrote the same problem. That's not what I meant. Log base 8 of 3. Log base 8 of x equals 3. Third time's a charm. Sometimes it's hard to get words out. Log base 8 of x equals 3. First step, restate it. Olivia. Sure. 8 to the 3rd power equals x. So x equals 512. Nice. Couple more examples. Example 7. I'm going to mix it up on you again. Log base 3 of x equals negative 6. Who can tell me how to translate that?
3 to the, that can be negative,
Mm-hmm.
okay. Equals x.
Okay, 3 to the negative 6th power. Negative powers just tell me take the reciprocal. So that's going to be 1 over 3 to the 6th power. That's something you're going to need to remember. The negative exponent rule. 1 over 3 to the 6th. 729. Good. Good. Well, for me. Maybe you. Maybe not you. That was example 7. Example 8 actually kind of starts to bleed over into lesson 7.3, which is your flex assignment for tomorrow. Hope you don't mind. We're just going to knock that out right now. I promise you I'll only do 4 more examples, and then we'll be done. So example 8 is 4 to the 3rd power equals 64. I want to restate that using logarithms. So that goes back to the very beginning. We did that in order to discover the definition of logs. We still have a base, an exponent, and a solution. And the beautiful thing is we can still apply the counterclockwise circle rule. So that gives me, yes.
Would it be log of 4 64 equals 3?
Yes, nicely done. And don't forget, we say log base 4 of 64 equals 3. But yes, you got it right. Log base 4 of 64 equals 3. That is it. You just have to be able to restate that. Example 9, 2 to the 5th equals 32. Who's got that one for me? 2 to the 5th equals 32.
Log base 2 of 32 equals 5.
Excellent. Log base 2 of 32 equals 5. There's no shame in drawing out the circle on your assignment. Two more. Maybe 3. Nah, just 2. Okay, example 10. Log base b of 49 equals 2. This is pretty much the last variation I could do. Back to exponential form. B to the 2nd power equals 49. And now we're applying what we learned in our last unit, which is how to solve when we square or raise to some power. We take the nth root, whatever the exponent is, we take that root. So we're taking the square root in this case, so then b just equals 7. Good. Last one. Log base b of 625 equals 4. Who can translate that for me? Aaron?
B to the fourth power equals
b to the 4th power equals 625,
625.
yes. Thank you. And you can use your Math 5 function in your calculator to take the 4th root of both sides and get our solution. So what raised to the 4th power equals 625? 5. Good. And that is your notes. 7.2 and 7.3.